This question is from C2 2017 and it's question 4. A girl invests £1,000 at 8% per annum compound interest. So first of all, with all of these, I always like to get the pattern going. So at the end of year 1, she will have 108% of 1,000. So that is 1.08 times 1,000. At the end of year 2, she's not adding anything extra into it, so she's going to have 108% of what she had at the end of year 1. So it's 1.08 as a decimal times 1.08 times 1,000, giving you 1.08 squared times 1,000. At the end of year 3, it's 108% again of what she had at the end of year 2. And now we're starting to see a pattern going. So it's 1.08 squared times 1,000, 1.08 cubed times 1,000. You want the end of n years. So year n is 1.08 to the n times 1,000. So that's the first question done. Then it says hence. That is a very important word. When it says the word hence, you must use your previous answer. So this is telling you the value at year n. We want to know when the value of the investment exceeds £2,000. So which year exceeds £2,000? So which year is £2,000 basically? So let's put our numbers in. 1.08 to the n times 1,000 equals 2,000. Bring our 1,000 over and divide. 1.08n equals 2. I actually want to know when it exceeds, so I should have a greater than sign in there. You've got an exponential equation, so you have to log each side. So log 1.08 to the n log 2. The reason you log it is you can bring the power to the front. Now bring your log 1.8 over to the other side. So you'll have n greater than 9.01. So i.e. you need 10 years. Okay, that's that part done. Part B of the question. Show that the first n natural numbers is that formula. Now that might seem a bit daunting at the beginning, but just think about it. What are they looking you to do? They're wanting you to find the sum of 1 plus 2 plus 3 plus the whole way up to n. So A is 1, it's going up by 1s each time, so the difference is 1, and the number of terms is n. So we're just using your normal formula for an AP, n over 2, 2a, plus n minus 1d. So Sn is n over 2, 2 times 1, plus n minus 1 times 1. And just tidying that out. 2 plus n minus 1 tidies up to give you n over 2, n plus 1. And that is exactly what they were looking for there. The next bit of this question does take a wee bit of thought. It's wanting you to find the sum of the integers as whole numbers between 1 and 600 that are not divisible by 3. Now, if the question wanted divisible by 3, it would be much easier. So let's look at that. Divisible by 3 would be 3 plus 6 plus 9, the whole way up to 600. So the first term would be 3, the difference, you're going up in 3s, and the number of terms you have is 200, because you're going to have 200 of those numbers there. So using your SN formula, it's n over 2, 2a plus n minus 1d. So 200 divided by 2, 2 times a, plus n minus 1, 199, and the difference is 3. And if you put all that into your calculator, you will get an answer of 60300. But the question didn't want divisible by 3. It wanted the ones not divisible by 3. If you look back to part 1 of that question, it's wanting you to find all of the numbers. So what I could do, I could find the sum of all the 600 numbers, just using your formula from above. So the sum of all the 600 numbers would be 180,300. These are the ones which are divisible by 3. So the sum that is not divisible by 3 is all of the numbers, add it up, subtract the ones which do divide by 3 to give you an answer of 120000. So that certainly is a tricky question.